Assalamualaikum and salam sejahtera everyone. First of all, thank you very much to the management of the faculty in organizing this wonderful workshop or session. And I appreciate the enthusiasm as well as the willingness of all the participants to participate in the workshop. So in this session, we will try to see on the methods to analyze panel data. So before we move into the application, let us at first try to understand some basic concepts that are important for our discussion. This workshop is actually a continuation of our previous session, where in the previous session we look into the time series data, while in this session we will focus more into the panel data analysis. So panel data is a type of data. Panel data together with time series and cross-sectional data are used to analyze secondary variables or secondary source of variables. So the panel data is actually a combination of cross-sectional and time series data. The cross-sectional data is a type of data collected by recording the characteristic or attribute of many subjects at one point in time or without regard to differences in time. So when we talk about subjects, the subject of interest can be varied. The subject can be individual, they can be household, firm, industries, region, and countries as well. The subjects, they can be micro variable, they can also be macro variable or macro data. For example, say that we wanted to analyze the CGPA for all UMS students in one particular semester, for example, semester 1, session 2019-2020. So that is an example of a cross-sectional data because you have various subjects, all UMS students, they are subjects at one point in time or same point in time. In this case, semester 1, session 2019-2020. The time series data, on the other hand, is in contrast to the cross-sectional data because in the cross-sectional data, we have multiple subjects over one point in time, while in a time series data, you have a single subject of interest. You record the attribute or characteristic of a single subject over multiple time periods. So these time periods, they can be in various frequencies. They can be hourly, they can be daily, they can be weekly, monthly, they can also be quarterly, annually, or they can also be in a different frequency. They can be in a lower frequency even than the annual observation. They can be in centuries, they can be in decades, for example. For example, say that we observed the CGPA for one particular UMS student from semester 1, session 2019-2020 to semester 2, session 2021-2022. In other words, we are observing the characteristic of one particular student for over 6 semesters. So in this case, we are conducting a time series data because we have one subject, multiple time periods. So the panel data, on the other hand, is a combination of both cross-sectional and time series data, where in a panel data, we observe the characteristic of various subjects or multiple subjects over several points in time. For example, we analyze the CGPA, or we collected the data for CGPA of all UMS students from semester 1 until semester 6, from semester 1 session 2019-2020 to semester 2 session 2021-2022. So panel data is a combination of both time series and cross-sectional data. So this panel data can also sometimes be called longitude data or longitudinal data analysis. The panel data analysis can commonly or generally divided into two categories: static panel data and dynamic panel data analysis. In the slide, you can see the equation for static panel data analysis, where the independent variable is explained by an intercept, a set of independent variable, and an error terms. We also have the symbol of IT, denoting the I cross-sectional items and T time periods. So this subscript here represents the panel data analysis, because in a panel data analysis you have both cross-sectional information and time series information. So you can read this equation as the dependent variable for I cross-sectional items at the time period is explained by an intercept for I cross-sectional item plus B1 beta 1, which represent the coefficient value for a set of independent variables for I cross-sectional items at T point in time, and error term for I cross-sectional items at T point in time. So this is a simplified version or a simplified equation for a static panel data analysis. In a dynamic panel data analysis, on the other hand, you have an additional independent variable, that is the lag value of the dependent variable. So a dynamic panel data means that you include the lag value of the dependent variable as the additional independent variable. There are various methods that we can use to determine or to help us to determine whether to use a static or a dynamic panel data analysis. Later, throughout our discussion, we will try to see what are the signs that can help us to determine whether we are conducting a static or a panel data or a dynamic panel data analysis. We will look into certain what we call as information that can help us to determine whether we will use static or a dynamic panel data analysis. So let us shift our focus by discussing the static panel data analysis. There are multiple methods or multiple models that we can use to run the static panel data analysis. But of course, three of the most common methods used for static panel data analysis are the fixed effects model, random effects model, and the pooled OLS. So in a fixed effects model, you have the dependent variable for I cross-sectional items at t point in time that is explained by the intercept at I cross-sectional items, a number of independent or a set of independent variable for I cross-sectional item at t point in time, and the error term for I cross-sectional items at t point in time. So in a fixed effects model, you have the intercept for I cross-sectional item that absorb all the variation across the cross-sectional items. In other words, in a fixed effects model, we assume that the variation across cross-sectional items are fixed. In a random effects model, on the other hand, we have the dependent variable for I cross-sectional item at t point in time that is explained by an intercept, by a common intercept mu here, by a common intercept mu it, which represent the variation across I cross-sectional unit at t point in time, a set of independent variable, and the error term for I cross-section, and the error term for I cross-sectional item at t point in time. So the mu here represents the between errors. So this mu here is also called as the the between error term. This between error term will record the differences across so this within it, this between error term here will record for the random effects model. On the other hand, we have the dependent variable for I cross-sectional entity at t point in time that is explained by the intercept between entity error for I cross-sectional entity at t point in time, a set of independent variable for I cross-sectional entity or I cross-sectional item at t point in time, and the within entity error for I cross-sectional item or I cross-sectional entity at t point in time. In a random effects model, we assume that the variation across entity as random. So this is different than the fixed effects model, as I mentioned before this, because in the fixed effects model, we assume that the variation or the difference across entity as fixed. So since in the random effects model, we assume that the variation across entity as random, we can include time invariant variable. For example, gender, race, nationality, geographical location, for example, in the random effects model. And if we believe that the differences or the variation across entity as important in explaining the dependent variable, then it is more appropriate to use the random effects model. Conversely, if we assume that the variation across entity as insignificant in explaining the dependent variable, then fixed effects model can be used to estimate our panel data information. But of course, apart from the fixed effects and random effects model, we can also use ordinary least square in order to identify or to analyze a panel data. But if we are using the OLS instead, then we will lose the information. Then we will use the information based on the cross-sectional data that we have inside the panel data. In other words, if I can rephrase it, if we are using the pool OLS, we will lose the information that we're supposed to be able to obtain. Okay? We will use the cross-sectional information that we're supposed to be able to obtain if we are using the fixed effects model and the random effects model. So another important information that we're supposed to be able to know as well between fixed effects and random effect is that if we are using the random effects model, then the variation across entities will be recorded by the within, it will be recorded by this between entity error, this mu here. While if we are using the fixed effects model, the information about the variation across entity will be absorbed by the intercept that we have in this specific component. Of course, just like previous estimation, just like previous workshop, there are various diagnostic tests that we can use to determine the validity of our fixed effects, random effects, and pool OLS estimation. And these diagnostic tests, certain diagnostic tests can also be used in order to help us to determine which models or which model that is more appropriate in order to analyze our research or in order to analyze our data. So in the fixed effects model, we have a variation of tests that we can conduct to identify the validity of our finding. For example, we have the Hostman test, heteroscedasticity, cross-sectional dependence, and the normality test. While in the random effects, you have the Bush-Fagan test, cross-sectional dependence, and the normality test. In the pooled OLS, just like the ordinary least square for panel data analysis, for the time series data analysis, we can conduct the heteroscedasticity, the serial correlation, as well as the normality test in order to identify the validity of our finding based on each panel data model that we have on this slide. So in order to help us to understand further about fixed effects, random effects, and pooled OLS, let me show you on how to run the analysis by using Gretl. Okay, I will show you how we can run the fixed effects, random effects, as well as the pooled OLS to analyze our panel data by using Gretl. Just like I mentioned before this, the reason why we are using Gretl is because it is a free software that is available online. So every one of you can simply download and then install that free software in order to analyze your panel data. So since I have installed it, so any one of you who haven't installed the Gretl, please feel free to do so in order to, because it is much more helpful to understand about how we can analyze the panel data if we do the analysis together. So you can find example of panel data from the internet as well. You don't have to create that, okay, in order to help you to what you call as understand our topic. Once you have installed the Gretl, try to find a free panel data example and then use that panel data example to test the fixed effects, random effects, as well as the pooled OLS. So since I have installed the Gretl, I can simply open it, and then here I have the sample of panel data. Click panel data. Since I have multiple sheets, I use the panel data sheet. Click OK. And then after that, we have this information. There are two valid sheets. As I mentioned just now, we have found 8 variables, 207 observations. Close. Here, you will be asked whether you want to give the data a time series or panel interpretation, because the Gretl inputted the data as undated cross-sectional data. So click yes, because we wanted to transform this data into a panel interpretation. So here, choose panel, click forward, choose either stack time series, stack cross-sectional, or use index variable. In our case, just choose use index variable and then click forward. So here, we can determine what is the variable that we wanted to use for our cross-sectional items, okay, or cross-sectional entity. So our cross-sectional entity is the country. We have 9 countries, because in this example we will try to see how the dependent variable will be influenced by a number of independent variables. And in this specific example, our dependent variable is the number of tourist arrivals, while our independent variables are the macroeconomic factors. So our time index variable is year. Click forward. So we have 9 cross-sectional units because we have 9 countries. Over 23 periods because we have 23 time series. We have 23 years of data. Click apply. So we have the information. You may close this if you want it. So we enlarge the screen. So here we have a number of variables. We have the constant term, we have country, reference, year, we have CPI, GDP, trade, and the exchange rate. If I can show you the raw data in Excel file, so in order to analyze a panel data, you have to stack the data based on the form that we have over here. So we stacked it based on country. Okay, so we have Brunei Darussalam as the first country, and then after that we will arrange the information based on year for each specific country. After Brunei, we have Cambodia. Same goes with time series information. We arrange it based on yearly basis in an ascending order until the last cross-sectional entity, which is Vietnam from 1995 to 2017. So that is how we arrange our panel data, by arranging it based on country, and in each specific country we arrange the yearly information or the time series information in the ascending order, in an ascending order. Save. You go back into the Gretl. All right, now we have the information over here. So from this we can already start to conduct the static panel data analysis. Let us see how we can analyze the fixed effects model first. So in order to analyze the panel data based on fixed effects model, we can simply click the model, choose panel data, and then choose fixed or random effects. So here we have the pop-up menu, or the pop-up what you call as option. So as I mentioned before, in this analysis we will try to see how the number of tourist arrival can be influenced by the macroeconomic variables. So we have 4 macroeconomic variables. We have CPI, we have GDP, we have trade openness, and then the exchange rate. So click tourist and then include it as the dependent variable. Choose CPI as one of the regresses, GDP, trade, and the exchange rate as well. So here we will choose the fixed effects. Click Okay, so we have the results for fixed effects model. So based on these results, we have several important information. For example, we have the coefficient value, the standard error, t-ratio, as well as the p-value for each of the regresses that we have. For the CPI, we can identify that the CPI is significant at 10% significance level since the p-value is less than 0.10. GDP is significant at 1% significance level because p-value is less than 0.001 or 0.00, while trade openness is also significant at 1% significance level because the p-value is less than 0.01. The exchange rate is also significant at 1% significance level since the p-value here is also less than 0.01 or less than 1%. Apart from the coefficient, standard error, t-ratio, and the p-value, we can also see a number of important information that may be important based on your analysis. Okay? So these additional information may be important for your analysis. So you should look into this information one by one to see if they are relevant to be addressed based on the analysis that you have, based on the assumption, based on the estimation that you conduct for your own research. And here we also have additional information apart from uh, the mean dependent variable, apart from the Akaike criterion, Han and Quinn, for example. We have extra information. So we have the joint test on name regresses, where the t-statistic is equal to 33.8897, and the p-value is less than 0.01. So this joint test helps us to determine whether the regresses are jointly significant in explaining the tourist arrival or not. And since the p-value is less than 1, we can safely say that the macroeconomic variables are jointly significant in explaining the dependent variable. So these macroeconomic variables are significant in explaining the number of tourist arrival, jointly significant in explaining the tourist arrivals. And additionally, we also have the test for differing group intercept, where the null hypothesis states that the groups have a common intercept. And the test statistic based on the F value is equal to 10.8608, while the P value is less than 1%. So since the p-value is significant, we can safely reject the null hypothesis, which states that the group have a common intercept. In other words, the groups has unique intercept across the items, okay, across the what we call as a entity that we have. So apart from that, we can also conduct certain diagnostic tests to identify the validity of our fixed effects model. So check test, and we can at first conduct the heteroscedasticity test. and choose group wise. Close this pop-up menu or pop-up result. Here we have the results for our heteroscedasticity test, where the distribution free wall test for heteroscedasticity states that the null hypothesis is the units have a common error variance. In other words, the null hypothesis states that we don't have heteroscedasticity. So the asymptotic test statistic based on chi-square value is 36,269.6, while the p-value is equal to 0. So since the p-value is equal to 0, so we can safely reject the null hypothesis where the units have a common variance. In other words, the unit don't have a common variance. In other words, we have the problem of heteroscedasticity. So among the simplest methods to fix the heteroscedasticity issue is to use the robust standard error, because keep in mind, when we have a problem with heteroscedasticity, the standard error reported is non-accurate. Okay, so they are not the robust standard error. So we do, when the standard error is non-robust, then the inference that we obtain based on the analysis will be inaccurate. So another test that we can conduct is the autocorrelation to identify whether we have serial correlation issue in our analysis or not. So close this pop-up result. Here we have the Woolrich test for autocorrelation based on the panel data, where the null hypothesis stated that no first order autocorrelation. So that is the null hypothesis assumption. The test statistic based on F value is equal to 721.931, while the p-value is less than 0.01. So in this case, we reject the null hypothesis of no first order autocorrelation. In other words, we have the issue of autocorrelation in the model. Another test that we can conduct. So before we conduct the last diagnostic test, which is the normality test, if I can simply explain what does it mean by the issue of serial correlation. So this serial correlation can be addressed by a number of steps or a number of measures. So among the methods that is used to correct serial correlation is to drop variables that are correlated, or some of the analysts log transformed their variables in order to fix the issue of serial correlation. Means these variables, CPI, GDP, trade, exchange rate, as well as tourist arrival, can be transformed into natural logarithm in order to identify whether the autocorrelation can be fixed or not. In other words, you can try to fix the autocorrelation or serial correlation issue by log transforming the variables that we have. Or apart from that, you can also try to increase the time period that you have in your data. So that are among the attempt that we can use, or that are among the measures that we can use to fix the autocorrelation. But of course, you have to conduct the autocorrelation test again in order to test whether the problem has been fixed after you have taken the measures that I have mentioned before this. So the last diagnostic test that you can, of course, there are a number of diagnostic that we can, what you call as uh, uh, use as well, but okay, elasticity, serial correlation, and normality of residual are three of the common diagnostic tests used by researcher when fixed effects model is employed to analyze the panel data. So based on the normality test, the null hypothesis states that the error is normally distributed. So the chi-square value is 488.205, while the p-value is equal to 9.7187, which is in this case lower than 0.01 because you have the information here which states that the p-value is less than 0.001, which is very low value, low p-value. So since the p-value indicates the rejection of null hypothesis, we can say that the model experienced non-normality in the residual. So we have a model that suffers from autocorrelation. The model also suffers from non-normality, and the model also suffers from heteroscedasticity. After this, let us look into the random effects as well as the pool OLS. Okay, let us continue our discussion by conducting the random effects model. So just like effects model, in order to conduct the random effects, all that you have to do is to choose the panel option and then choose fixed effects or random effects. And then here we use the number of tourist arrival as the dependent variable as well, and we maintain the regresses. And of course, instead of choosing the fixed effects, we will choose the random effects. So when we choose the random effects, there are a number of options that are available. We have Swami Aurora, we have Swami Aurora Baltagi Chang, and we also have the Null. So all of these, what you call as options, are different methods used to estimate the variance components. So Swami Aurora, Baltagi Chang, and Null are all used to determine the variance components. But of course, let us choose the Swami Aurora, which is the default choice based on the Gretl, and click OK. Here we have the result for the random effects model. We have the coefficient value for each regresses, standard error, z-value, as well as the p-value. And based on the p-value, CPI, Consumer Price Index, is not significant in explaining the tourist arrival, while GDP, trade, and exchange rate are all significant in explaining the tourist arrival at different significance level. So the GDP and exchange rate are significant at 5% significance level, while trade openness is significant in explaining the tourist arrival at 1% significance level. We also have additional informations that you may try to refer to based on your estimation. Okay? So you may refer this additional information because they may be important to be looked at based on your estimation. Apart from that, we have the between variance, we have the within variance, theta used for quasi-demeaning as well as the correlation squared value. So the joint test on name regresses is that the asymptotic test statistic based on the chi-square is equal to 123.652, where the with the p-value that is significant or less than 0.01. So just like the fixed effects model, this joint test on the regresses helps us to determine the joint significance of the regresses in explaining the dependent variable. So since the p-value shows significance, it means that, or we can imply that the macroeconomic variables are jointly significant in influencing or explaining the number of tourist arrival. So apart from the joint test, we also have the Bruce-Pagan test, which will help us to determine either to use the random effects or the pooled OLS. So that is the purpose of the Bruce-Pagan test, where based on the null hypothesis, it is stated that variance of the unit specific error is equal to 0. So in other words, when the variance of the unit specific error is equal to 0, it means that the difference across the cross-sectional what you call as item, or the differences across the cross-sectional unit are not significant in explaining the dependent variable. So the asymptotic test statistic based on the chi-square value is equal to 104.575, while the p-value shows significance in rejecting the null hypothesis. Since the p-value is less than 0.01, we can simply reject the null hypothesis of the variance with the unit-specific error that is equal to 0. In other words, we can simply say that random effects is appropriate than the fixed, is more appropriate than the pooled OLS, because it is identified that the variance across entity are significant in explaining the dependent variable. This Hausman test, on the other hand, is used to compare between between fixed effects and random effects. Null hypothesis states that the GLS, or generalized least square estimates, are consistent. In other words, the null hypothesis states that random effects is consistent. In other words, you can use random effects model compared to fixed effects. The asymptotic test statistic based on the chi-square is equal to 12.0175, and the p-value is less than 0.05. In other words, we can reject the null hypothesis where GLS estimates are consistent. So, since the null hypothesis is rejected based on the Hausman test, we can say that fixed effects is more appropriate to be used than random effects. Fixed effects is more appropriate to be used than random effects. Remember, in the fixed effects model, we assume that the difference across the cross-sectional units, or the difference or the variation across the cross-sectional entity is fixed. They are not random. So a number of diagnostic tests that we can use will be the normality, autocorrelation, as well as the cross-sectional dependence. So based on the normality of the residual, you can close the pop-up option or the pop-up result. You can simply say the result for the test of the normality of the residual, where the null hypothesis states that the error is normally distributed. The test statistic based on the chi-square is 200.401 and the p-value is less than 0.01. So since the p-value is less than 1%, we reject the null hypothesis where the error is normally distributed. In other words, we have the non-normality of the error term or the non-normality of the residual. So we may try to fix the problem of non-normality. For example, we may try to log transform the variables. We may try to use different proxy for our variables, or we may try to increase the number of time periods for our data as well in order to fix the problem of non-normality in the estimation. So apart from that, we can also conduct the autocorrelation test. We close this pop-up result. So this autocorrelation test is based on Woolrich, where the null hypothesis is that we have no first-order autocorrelation. We are free from serial correlation. And the test statistic based on the F value is 723.931, while the P value is less than 0.01. It is less than 1%. Thus, we reject the null hypothesis of no first-order autocorrelation. In other words, we have a problem of serial correlation in the model. So, this autocorrelation implies a number of what you call as situation. So, this autocorrelation or serial correlation may imply that we have failed to include certain variables that may be important in explaining our dependent variable in the model. If I can repeat it again, this autocorrelation may happen because we fail to include certain important variables as the independent variable in the model. This autocorrelation can also happen when we estimate a model that's supposed to be dynamic. Sometimes when we estimate a dynamic model as a static model, we may suffer from the problem of autocorrelation, because autocorrelation, as I mentioned before, this may happen due to the failure of including an important, due to the failure of including a significant variable as one of the independent variable in our estimation. So we have to look into other options. We have to look into other possibilities that may cause our estimation to experience autocorrelation. And one of the possibility is that, as I mentioned before this, one of the possibility is that our model is supposed to be a dynamic panel data estimation instead of a fixed effects, or instead of a static panel data estimation. So of course, we can also conduct the cross-sectional dependence. We can close this. So here, based on the Pasaran test for cross-sectional dependence, The null hypothesis states that there is no cross-sectional dependence and the asymptotic test statistic based on z-value is 8.9993 while the p-value is less than 0.01. So since the p-value is less than 1%, we reject the null hypothesis of no cross-sectional dependence. In other words, our model have cross-sectional dependence. So that is how we conduct the random effects model. So last but not least, let us look into the pooled OLS. So the pooled OLS in a panel data model is similar to the ordinary least square for a time series data. So if we are using the pooled OLS to analyze a panel data, we will lose the information that we're supposed to be able to obtain, because in the ordinary least square, the information that we obtained will be focusing towards the time series information. Nevertheless, it also states that the pooled OLS is sufficient to analyze the panel data. So even though we are using the pooled OLS, it doesn't mean that it is not appropriate compared to fixed effects and random effects, because based on certain tests, we may conclude that using the pooled OLS is sufficient to analyze our panel data. So in order to test whether the pooled OLS is sufficient or consistent in estimating the panel data analysis, we can simply use the Lagrange multiplier test, because the Lagrange multiplier test in a random effects model will help us to determine whether we use the random effects or we use the fixed effects model. So here you can see from this note, it states that the Lagrange multiplier test help us to decide between a random effects regression and a simple OLS regression. So the null hypothesis in the Lagrange test is the variance across entities is equal to 0. In other words, there is no significant difference across the units. In other words, there is no panel effects. If there is no panel effects, we can simply use or run the pooled OLS to analyze our panel data because we don't have panel effects. Okay. So in order to run the pooled OLS based on the Gretl, click Model, choose Ordinary Least Square, choose number of tourist arrival as the dependent variable, and we maintain the regresses for CPI, GDP, trade, and the exchange rate, and simply click OK. After that, here we have the results, and of course we have a number of important information for each of the regresses. We have coefficient, standard errors, p-ratio, and the p-value. And based on the p-value, CPI is not significant, while GDP, trade, and the exchange rate are significant at several significance level. So the GDP is significant at 5% significance level, while both trade, openness, and exchange rate are significant at 1% significance level. Apart from this important information for each of the regresses that we have, we also have important information for the model. We have mean dependent variable, we have Schwartz criterion, we have the adjusted R-square, we have the Hannan-Quinn, for example. So all of this important information, you're supposed to look into this important information for the model because it helps you to determine whether your model is valid or not, yeah, based on certain characteristic. So of course, apart from that, we have several diagnostic tests that can help us to determine the validity of our model as well. So in a pooled OLS, you may run for the heteroscedasticity test, either based on white test or group-wise. So let us try to use the group-wise as well. We can close this pop-up result, and here we have the result for the what you call as a heteroscedasticity based on wall test, where the null hypothesis states that the units have a common error variance. In other words, the unit doesn't have the heteroscedasticity. So the asymptotic test statistic for chi-square is 29,131 with the p-value that is equal to 0. So since the p-value is less than 1%, in this case 0, we reject the null hypothesis of the units that have a common error variance. In other words, we have the problem of heteroscedasticity in our model. So if you have the problem of heteroscedasticity, we may try to run the robust standard error model because it will what you call as based on the robust standard error, we will have a standard error that is accurate. That is, when we have a standard error that is accurate, then the inference that we used in the model will be precise. Apart from that, we may run for the autocorrelation. So here we have the result for Woodridge test for autocorrelation, where the p-value is less than 1. So based on the null hypothesis, we don't have first-order autocorrelation. And unfortunately, since the p-value is less than 0.01, we reject the null hypothesis of no first-order autocorrelation. In other words, we have the problem of autocorrelation in the model. We can also conduct the normality test. We can conduct the normality test of the residual. We can simply close this pop-up result. So based on the test for normality of the residual, null hypothesis states that the error is normally distributed with the test statistic for chi-square is 742.761. So the p-value here is less than 0.01 or less than 1%. So we can conclude that we can reject the null hypothesis of error is normally distributed. In other words, our residual is not normally distributed. They are non-normal. So these are among the tests that we can use, diagnostic tests that we can use to identify the validity of our pooled OLS. But of course, based on the overall estimation that we have done so far, we have done the pooled OLS, we have done the fixed effects, we have done the random effects, and all of them have several problems. They have the issue of non-normality, they have the issue of heteroscedasticity, and they also have, or they also suffer from serial correlation. As I mentioned before this, these problems indicates certain what you call as a issue in our model. It indicates certain issue in the model. So in order to fix these issues, heteroscedasticity, non-normality, or autocorrelation, you may try to increase the number of variables that you have, or you may try to use different proxy for your variables. You can also try to log transform your variable, or you may try to include significant variables that you fail to include in your estimation, especially when we are referring to the problem of serial correlation. Because this serial correlation means that there are significant variables that we fail to include in the model. Yeah. So since we fail to include this since we fail to include this variable in the model, the information for that significant variable will be recorded in the error term. So it causes the error term to be significant in influencing or in explaining the dependent variable. Keep in mind, even though we have the error term in the model based on this equation over here, when we run the analysis, the error term is supposed to be equal to 0. Because if it is not equal to 0, it means we fail to include certain variables, certain important variables. So when we fail to include these important variable, that means our variable has a weakness where it failed to include variables that are significant in the estimation. So that are among the conclusions that we can find, or that we can imply based on the results that we have, and say that we don't have, or you are free from heteroscedasticity, we are free from serial correlation, we are free from non-normality issue. We can also conclude that the GDP, CPI, trade and exchange rate are important, especially when we are referring to the fixed effects model. While based on the random effects and the pool OLS, GDP, trade openness, and exchange rate are important, while CPI is not significant in explaining the movement of the number of tourist arrival. So, of course, there are other what we call as static panel data analysis that we can use, that we can use apart from the fixed effects, random effects, and pool OLS. But we will save the discussion on that different methods of static panel data analysis apart from fixed effects, random effects, and OLS for another workshop. So I think that's all for now. So again, I would like to say thank you to the faculty management for organizing this wonderful workshop, and I hope that all of you are able to obtain some knowledge, useful knowledge for your study based on the discussion that we have in this workshop. And apologies if I have, if I have mentioned inaccurate information. And of course, as a postscript, as a disclaimer, if we can call it as a disclaimer, I use loose term, yeah, in order to explain some of the concept so that it will be easy for all of us to understand. Thank you very much and see you next time.